Hello students, I am Dr. Gajendra Purohit. Welcome to our YouTube channel where I upload videos for engineering, B.Sc mathematics. I've also launched Infinite Series 2.0. That means I have already taught that on the green board and now I have tried to improvise the content somehow. And students, before this, I have also uploaded 2 videos about the infinite series and what is P-series test and what is necessary and sufficient condition here. And then after that, I have also explained the geometric series to you here. Today, I am going to explain you about the comparison test which we will be using to determine if a series is convergent or not. Let's look at it. If we have 2 series given here and both are positive term series, you need to determine that how the series un and vn are related to each other. Specifically, when we have such a relation between these values that the mod of un is less than or equal to the mod of vn. And if this series that we have is convergent, right? If this series is convergent, which is the bigger one, so the smaller series would be absolutely convergent, right students? And if this smaller one exhibits divergence, then this bigger one will also demonstrate divergence as a matter of course, right? Now, I will proceed to provide you with a series of examples to make you understand the reasons for why this series exhibits the behavior that it does through some examples. Right, students? Okay, I want to repeat again that if the larger series is convergent, the smaller one must also converge. Conversely, if the smaller series diverges, the larger series will inevitably diverge. Let's take an example to understand this. So, we have a question here which says 1 upon n square sine 1 by n. So, at this time, we have un. This is the un, right students? So here, if I proceed to take 1 upon n square sine 1 by n. So we know that if we take the modulus of this term, then in that case, the value of 1 upon n square will be greater than the value of this term, right students? And if it is bigger than this, we know that this is always. If I explain this before you now, the 1 upon n square series with n is equal to 1 to infinity. So by the P series test, it is always convergent. And if this one is convergent, then the smaller one by default will be convergent. We can easily prove it this way. So students, let's look at this question. We need to figure out if this is convergent or not. So you know what you have to do. First of all, let me tell, n square minus cos square n. Students, it is n, right? Cos square n. So we know that the value of n square will be greater than the value of this because it is subtracting. Do you understand? And now we will cross multiply. So this will become 1 upon n square and this will be 1 upon n square minus cos square n. Now students, we will multiply both the sides with n, and when you multiply it, this will become summation n upon n square minus cos square n. So now you see here n cancels n. So 1 upon n will be n upon n square minus cos square n. And we know that this series is by P series, n is equal to 1 to infinity. This is divergent from the P series test. If this one is divergent, then the bigger one by default will be divergent. So you can understand this easily here. So the next question is about, here summation n is equal to 1 to infinity e to the power minus n upon n plus cos square n. You have to find out whether this series is convergent or divergent. So students, we know that this n plus cos square n will obviously be greater than this n, right? Because it has a plus in it, right? Now what do we do with this? We cross multiply it. So this is 1 upon n plus cos square n is less than or equal to 1 upon n. I did cross multiplication, right? Since we need e to the power minus n, so I multiplied both sides by e to the power minus n. So e to the power minus n, n plus cos square n is less than e to the power minus n upon n. But we know that e to the power minus n would be greater than this because n is divided. If we check whether this converges or not, then we can make some decisions about it. So what will we do in this case is take a look at the summation n equals 1 to infinity for e power minus n and see whether it is convergent or not. Start from 0. So the summation n equals to 0 to infinity. This can be written as 1 by e power n. It is negative, so it will be 1 upon e power n, and I took out the n. If I expand this here, students, if we expand it, then it's 1 plus 1 by e plus whole square of 1 by e. We know that this is a geometric progression. Here, the value of r is 1 by e and this is less than 1. And if it is lesser than 1, then we know that through geometric series test, this will become convergent. And if this is convergent, then this is without doubt convergent as well. Right, students? So we do it this way. If you're unfamiliar with geometric or P-series tests, then you can check my previous video on my iTab so that you don't have problems understanding it. So, students, see this question, n square plus 2 upon n power 4 plus 5. Okay, so we can solve this question with a method which I will explain to you later, and we can also solve this using comparison test. Let's see how. First, we see that n to the power 4 plus 5. Obviously, this will be greater than n to the power 4. Now, do cross multiplication. It will be n power 4 plus 5 is less than 1 upon n power 4. So, I multiplied it this way. Now, I'll multiply it by n square plus 2. So, when you multiply this by n square plus 2, so what will we get after multiplying is this. This is what we get. Now, we'll see whether it converges. If it converges, then we are good. So, let's see the summation. N square plus 2 upon n power 4, where n equals to 1 to infinity. So, summation n is equal to 1 to infinity. And if I divide this by this, then we will get 1 upon n square plus, let me separate the summation. N is equal to 1 to infinity. This will be 1 upon n power 4. We divided them and separated them. We know this converges by the P-series test. It is also convergent. And if we have two convergent series, then their sum will also be convergent. And if this is convergent, then this will be convergent by default by the comparison test, right? So that is how we can easily do this here. Now, next question, students. See, we have been asked n upon n cube plus n plus 1. Is this convergent or not? So, students, we know that the n cube here will be smaller than this n cube plus n plus 1. Now, do cross multiplication. So, here we get n cube plus n plus 1 is less than 1 upon n cube. So, students, multiply n with both the sides. And when you multiply n on both sides, and when this will be multiplied by n, so it will be 1 upon n square. And we know that this series summation of 1 upon n square, where n is equal to 1 to infinity, is convergent. So, if this is convergent, then this will also be convergent. In this way, you can do it easily. So, next you are being asked to check the convergence of this. So, let me tell you, students, that this log n is smaller than compared to the value of n, right? If I do cross multiplication of this, then we get 1 upon n and 1 upon log n here, right? So, as we are fully aware that this particular series represented as 1 upon n is divergent according to the P-series test. And if this is divergent, then what is this? If the smaller one diverges, then by the comparison test, the larger one also diverges. So, this is divergent. So, we can do it very easily this way. And you need to comment the answer for me in the comment box and also share how many seconds it took you to solve. Please let me know in the comments. If you want to watch more videos like this, then you will find the entire playlist here. If you are preparing for CSIR NET, GATE and IIT-JAM exams and you want to improve your short tricks, so guys, you can check out my videos here and subscribe to the channel. Thank you so much, everyone. Thank you. Bye-bye.